My name is Pietro Grande. I'm working as front-end developer at since I have some problems. I'm working as front-end developer at Betson Group, which is a gaming company. And I started working with WebGL in 2012. I was born, of course, as a 3D artist. That's why my career began back in the days. And that's also why I ended up working with WebGL and the 3D web. On the community side, I'm the co-founder of the Kronos chapter Milano, the only Italian chapter of Kronos Group, which is the organization. Okay. We have some special actors. Moreover, I founded the Open Tech School WebGL workshop, the only one from Open Tech School, both in Berlin in 2012 and in 2015 in Milan. And then I also had the workshop, WebGL workshop, at one school in Bologna during 2015. Okay. In the meanwhile, if you can hear me, I would like to go further. Unless... Okay, first question, why the web? Maybe a lot of you developers, you already are working with native applications, native libraries, native frameworks, delivering desktop contents or mobile content. So why the developers should choose to go with the web? First of all, the web is everywhere as of today. It's available either on desktop or mobile devices, and with desktop I mean also TV, smart TV, and wearable devices like clocks and eyeglasses. Almost any device is able to access the web, more or less. Moreover, the browser itself has become a very, very interesting environment for the application, for the web application, and we noticed it because of the frameworks like Angular, React, JS, or RIA. They are all aiming to host a big application inside the web stack. This is because of the faster JavaScript interpreter of the browser, like the V8, Chrome, Firefox, the last charter from Microsoft. And moreover, because of the standards. The web is made of standards. It's made of HTML5, CSS3, WebGL itself, we're going to see in a while what is it. And those standards don't depend on just one company. Rather, they depend on over the community. They depend on the community, they depend on consortium. So not just one company. And moreover, you have just one stack in order to rule them all, mobile, desktop, and wearable devices. So the next question comes is why? Let's see what. I think he's complaining for my talk. So WebGL is a native API. It's an application programming interface available in the browser, and it is meant to be accessed using JavaScript, plain old JavaScript. It represents the porting of OpenGL Embedded System 2.0, which is a version of OpenGL, which is meant to be used onto the embedded system, which are notoriously weaker, especially compared with desktop system. It allows our software to access directly the GPU, the graphic processing unit. And moreover, it is maintained by the Kronos Group. The Kronos Group is a consortium, and it comprises several companies like Google, Silicon Graphics, Apple, and it is in charge to maintain OpenGL standards, WebGL standards, Collada standards, and several other standards which are widely used in the industry. So it's not dependent over just one company. It is I told you that it is a native API, WebGL. What does it mean? It means that we can access it using JavaScript, plain JavaScript, JavaScript again. So no plugin required, no Flash, no Silverlight, no external libraries, no strange executables for Windows environment. Basically, no antivirus issues or security issues from the IT. All we have to do is just to create and provide a canvas element, which is a standard HTML element, and from then retrieve context and then start working. I told you that WebGL is based over OpenGL. What is OpenGL? It's an industry standard, and it is maintained as well by the Kronos group itself, and it's based over shader. It delivers a shader-based pipeline. We are going to say soon. We're going to see soon what does it mean, a shader-based pipeline. For now, let's see what is a shader. A shader basically is just a very small piece of application. You can think about it as a subroutine, which is in charge to calculate data. Basically, it's taking some input and putting out some output. We have two flavors of shaders while using WebGL: the vertex shader and the fragment shader. The vertex shader is being executed in order to retrieve the correct position of any geometry. Geometries are built of vertices. So for each vertex, the vertex shader is being executed by the underlying subsystem. The fragment shader is in charge to calculate the final color of the pixel, because you have a 3D scene, a 3D world, and you need to project it over a 2D canvas. It's very similar to how a camera is working, actually. So basically we have two hooks into the pipeline in order to access and modify data, or the way the data are calculated. The shader, of course, in order to achieve such a result, needs to exchange parameters with your own application. So just using JavaScript, you exchange parameters, and please note that is a one-way communication. You just send the data to the shader. You usually don't retrieve data from the shader. The GPU is retrieving. They are compiled. This is a great news. They are compiled because they are not written in JavaScript, but rather they are using a GL cell, which is a GL shading language, version 1.0. And this shading language is the same used into the OpenGL environment. So if you already know OpenGL, you're ready to go for WebGL, basically. It is mapped one-to-one. They are compiled, so we need to link shaders and then compile them. The linking process is in charge for compiling the shader. Then tell the subsystem which shader to use, and then load the geometry data, the vertices, and then order the subsystem to draw those vertices. Last but not least, WebGL is an immediate mode API. What does it mean? This scene is being written. Okay, it's not my data. Can you go? Oh. Okay. The scene is being redrawn each time for each iteration, and it's being redrawn in its order. So there is no scene caching by the subsystem, and this means that your application is in charge to keep, to cache the scene and interact with such a history of the scene. I tell you this because sometimes people don't know this. They start developing, and you start drawing points, on the GPU, and they disappear as soon as you draw something new. This is because of the immediate mode API. You have to track your own history. What is the support as of today? When I started back in 2012, it was possible to use such a technology just on Chrome. Not all Chrome versions, and not on every operating system, not on every graphic card adapter. As of today, the situation slightly changed. all the main browsers like Chrome, Firefox, Explorer from the 11 version, and Microsoft Edge and Safari. They are all supporting WebGL out of the box, so you can use it. And they don't have somehow prefixed stuff. It's just plain WebGL. The same instructions are valid all across the browser. Sorry. What about the mobile? When I started back in 2012, it seemed like a big bet, because iOS wasn't supporting it, and Apple told that they wouldn't support it anymore. Then in 2013, they decided to support it, starting from iOS 8. So as of today, you can use a WebGL almost everywhere. So we're going to use the WebGL, and today I'm going to show you and to explain you how some frameworks built on top of WebGL are working. So the next question, of course, is yet another JS framework. I mean, there are a lot of JS frameworks, and I don't like to use framework when I develop. So why should I go for a JS framework? The answer is that WebGL API is offering us just primitives. You can basically manage and draw dots and their connection, the way the dots are connected, and lines, of course, which are the connection, and triangles. This is all you have to work in a 2D environment. Of course, you have forwards and texture support. You can easily understand that such a toolbox, even if it's very powerful, is not what you need for a complex real-world 3D application or games. Because the world is bigger. The world is made of polygons, several polygons of every shape available. It is made of solids, very complex solids. Can you imagine to describe a solid just in a matter of triangles? Of course, probably someone of you already did it for like an exercise working with the graphics, but you know, it's not something you can do always for any new application. There are also fluids, which are kinds of strange elements for the real world, like fire, water, oil. And then you have material. Material is not just the color. The material is not just the texture, which actually is the color. The material is basically the sum of the physical properties of the surface and its light. There we go. And it's the surrounding environment. So lights, the neighbor objects, projecting shadows, projecting reflections, reflecting lights, sorry. So, just to make it more clear, I prepared a very trivial example, a red square. And we have the first red square here. I put them on GSP because I'm lazy. And what are you seeing? A red square, very simple, trivial. What are you seeing here is the WebGL, vanilla WebGL code I use in order to deliver just a square. And sorry, I have also the code open on the editor so we can go through it. Okay, basically we have the HTML and the JavaScript. We are taking the canvas, we are retrieving the context, we are providing shaders. Even for such a trivial example, very humble example, like can be a red square, we need vertex shader and a fragment shader, which basically are just acting like a pass-through object. They're just taking vertices and throwing them down into the subsystem. and taking the pixel and throwing it up to the frame buffer. Then we have to initialize the buffers, to initialize and compile the shaders, creating a program, and then we can start. We can start figuring out our scene at line 53. We just starting. Then we are further. We need to assign the vertices to our buffer. We need to assign the position to our buffer. And then finally, at line 68, we can draw it. The small red square. And it's not even 3D, this one. It is just composed by 2 triangles. Now, let's have a look to another example. The same scene, coded with using 3JS, which is yet another JS framework. It's this one. Basically, I start, I retrieve the canvas as well. I'm telling the WebGL, I'm telling this, the framework to create the renderer using my canvas. I pass some parameters, I create a scene. So you see, it's also easier to read, especially if you come from the 3D world. So you don't have to think about programs, shaders, and stuff like that. You just create a scene, you instance the renderer, you create a camera, which is more familiar. I haven't created a camera in the other example. And on top of that, we'll still... Yeah, thanks. Sorry, I'm not this famous guy, I don't know how to put him. Okay. Ready? Okay.
Turn off the code.
Actually, it is off.
Yeah,
so, back on the code, the most interesting part. And so, actually, we're creating a scene, we're adding a camera. In the previous example, we didn't create a camera because we didn't need. We are creating here a box geometry, and actually here we are creating a 3D geometry. Those are not 4 vertices; those are 8 vertices, and it is being all created out of the box. So under the hood, I'm creating a costume material. The most basic one. I try to keep this as trivial as possible, but yet this is more complex than the other one, and it's way shorter. And finally, render it. So, I told you there are several frameworks. I told you that I did it using the JS. So you probably are thinking, is there a killer framework like the JS? The answer is no. The answer is that there are several frameworks as usual, and I selected just the four with which I had the pleasure to work during my past jobs, my passion, my spare time as well. And those frameworks are 3JS, WebGL and JS, and of course, you should have told me. We were still looking into code. I was looking at the next slide. Okay. So, I told you, 4 main frameworks. The 4 I used so far, and the 4 are the biggest, I think, so far. One is 3JS, one is WebGL and JS, one is OSGJS, and the last but not least is Scene.js. let's start with JS. What is JS? Is a JS framework for WebGL. And it has been developed at the very beginning for Flash with Actions. And it has a community-driven developer. There is no company behind it. And the community is huge. And it is probably, not probably, is for sure the biggest community behind the framework of JavaScript. It is actually a complete game engine. It's not just a renderer. And it is delivered as with the MIT license. This is the most famous one. For sure, if you go for it, you will find tons of tutorials and examples. And the problem is that they always break something when they release a new version. So the examples are across the web are all broken. The next one is WebGL and JS. It has been developed at the very beginning for Microsoft Silverlight, and it's supported by Microsoft. It is being developed by Microsoft. Actually, they published it in 2013 as the new big answer for WebGL. It is a complete game engine. It's even more complete than JS because it provides also some functions and libraries for physical and physical stuff, you know, simulation like collisions, fluids, and so on. And it is being released with Apache license 2.0. The next one is GJS. It is based on OpenStreetMap. Maybe some of you already know what OpenStreetMap is. Actually, it is a framework written in C++. It is very famous one, kind of legacy stuff. And if you have experience over it, with GJS, it is mapping one-to-one, basically. It is being used by Sketchfab, and that's the reason why I worked with it. And it is just a plain rendering engine. It just started supporting animation last year, but it's not as complete as the first two. It is being released as with the MIT license. The last one is SyncJS, a pure rendering engine with a bit of support for animation. It has a declarative approach. This is curious because while the other has a procedural approach where you have to create the object and add to the scene and define the relationship. With SyncJS, you just provide a JSON object, kind of JSON object, because that actually is a JavaScript object, contains function and stuff like that. And this is pretty interesting. It is being used, the power user of SyncJS is Digital Human, which is a huge project. It provides real-time visualization for basically a human model. You can navigate inside, you can go under the skin. It has medical value, let's say. It's pretty interesting. If you have a time, it's nice. And has a custom open source license. I mean, there is no license, but they are sharing it and spreading it across the web. So probably would be nicer to ask them what is the license. So what about 2D? I talked about 3D for WebGL, but WebGL is not just 2D. The power of WebGL is that it provides a native function for vectors and matrices manipulation, which is the most expensive calculus for JavaScript environment as of today. So in the end, you can implement a 2D engine or use one 2D engine for 2D games, and you can get the GPU power for the real-time rendering, and you can use it for filters and the texture blending for real time, which is pretty expensive. The only famous engine for 2D using WebGL is PixieJS, which is very, very famous. It's amazing fast, really. And it supports animation, and it offers blends and filters and blending for textures and color, and sprites, very good sprites and event management, using WebGL. So it's accelerated. So cool. A lot of frameworks, a very nice technology, web stack everywhere, 3D the clock, and is someone really using it? Actually, I was surprised when I was preparing this talk. because someone is using it. The first one is Google Map example. Google Map provides, as you know, a big data visualization challenge. You have to deliver maps. You have to deliver data over maps. And everything it is very fast if you think about what is behind Google Maps. It started 4 years ago to draw vectors instead of tiles. Maybe you noticed the improvement in the last years using Google Maps. When you zoom, you don't have to wait for the tiles anymore, because the scene is a vector scene. It is being drawn in real time, and it's way faster, and it allows for animation. While the tiles, the bitmap tiles, basically rasterized images, they're not that big quality you can achieve. So basically, Google started doing it, and they're not using a framework as far as they allow us to know about it. And they did it mainly for performances. The second one is Autodesk. Autodesk is the world leader for computer graphics software. It is, I don't know whether you know, but it is the vendor of Autodesk, Max, Maya, and really a huge collection of other software, which are basically is representing an industry standard. And moreover, Autodesk is participating in the Chrome School. They started developing an online viewer using Flash back in the days in order to allow you to upload a DWG file, edit it, add some notes, and then download it. It was amazing because the AutoCAD license is pretty expensive if you have to exchange such file, and I had in my previous job. You have to pay the license, of course, not credit. And they decided to go for 3JS and WebGL, and they developed the A360 viewer, which is basically the same viewer and editor, an online one. You can use it in the browser, and it is based on 3JS. It's amazing. And moreover, they are also supporting the publishing of Revit projects. Revit is quite a big software, bigger than expensive software for civil engineering. It allows you to publish 3D models and animation using WebGL, basically. Moreover, they went one step further because they are providing an API for developers. So instead of using a framework, instead of using plain WebGL, you can get the API from Autodesk and use those API in order to convert models, to upload your models inside your own application, and display 3D environment, even interactive ones. It's not that big interaction, it's just for visualization. Last but not least, Unity. Unity is a very famous game engine. And it has WebGL as a publishing target. They started using it in 2014. They made up, they built a proof of concept during the Hackers Week. And then they started supporting it as experimental. So you can do it, but please don't sell it. From version 5.3, they started supporting it as an official target. And it means do it, pack it, sell it. Ready for the market. At least this is what I hope. They're using, it is a pretty curious example because they're using MScript, which represents a subset of JavaScript, using the use ASM directive for the JavaScript interpreters. And it allows for a faster JavaScript because it constrains you to use just a subset, to use a type array, and to use bitwise operators. Basically, all the contrary of Crockford. And they are using a custom framework. I don't know much about their framework because they didn't release it yet. What is amazing is that even then decided to go for this way. So we have product visualization, architecture industry. Google is kind of services, and Unity, which is a game industry. So of course, big companies spend money. they can afford, let's take this team and let's study for WebGL and then throw it away and go with another technology. What about me? I'm here to tell you use WebGL and here to tell you use whatever framework you want. Actually, yes, I did it. I worked in the industry and I did some products using WebGL. The first one is the UI, which the aim of the UI is to navigate and interact the environment. The reason why I can show so much is that it's not to be sold to the public, kind of reserved stuff. And I went to WebGL, for WebGL, it was 2013. The project has been delivered in 2015. Then I resigned. They started selling it, and then as of today they are selling it and it's working. Another work I did with WebGL was a data visualization program. A big Italian company needed to visualize and deliver a map showing hundreds of thousands of points. And they wanted a real-time zoom, panning, real-time update, you know, to hundreds of thousands. It's kind of, okay, no DOM. The first thing I told them is, please don't use the DOM. Don't use the DOM. It's going to explode. And the second one was not to use SVG, because even SVG, which is DOM actually, is too heavy, 200,000. So I went for WebGL. I didn't use any framework for it. I just used plain old WebGL. And it worked, actually. At least the POC worked. The online viewer is the only thing you are allowed to see is Sketchfab, actually, sketchfab.com, because I worked with them in 2012. And I worked on the material editor. You can try it online. It's awesome. And it is based on WebGL, and it is using JS. So, last but not least, Microsoft released in 2012 a security report stating, actually, we're not going to support WebGL, and this is why we're not going to support it, because of security. Apple didn't publish anything about that, but they just postponed it. Like, we're not going to support it now. We're not going to support it later. We might support it in the future. So let's have a look, because if you're planning to embrace this technology, if you're planning to use it probably in your own company, you're going to face such a question. Historically, the problem is that historically the graphics world is weak. It's weak for security, under the security point of view. That's because it is being used in real time, a real-time call for performances. And performances are not the best friends or best practices or security-related practices. There are less checks, and especially it is weak when it has to face buffer overflows attack, illegal memory access, even frame buffer can be hacked. You could be able in some environment to access the space outside your window, trying to read. Of course, you have to read an image, so it's not that straightforward, but actually you can. And the denial of service. You may have experimented denial of service while gaming. Simply, the graphic card crashes, and Windows crashes, Linux also crashes, everybody crashes. The main problem is because of the untrusted code. So, web application is not installed. The user doesn't really choose. This is my application. I want to install it. So I know the publisher, I know the developer. It is everything alright. It is kind of untrusted code. It is giving you hardware access, and that's very harmful. And basically, you have no control over the code. This is what Microsoft is stating, and it's true. Absolutely, that's true. You are allowing untrusted code because you are hardware. Actually, WebGL is not OpenGL. For instance, the new allocated memory is being zeroed. There is no way you can allocate new memory like a new buffer and try to read what's inside before initializing, because it has already initialized. A pixel outside the buffer, it is to be set to 0000. So basically, you are reading nothing transparent pixel. This is as per WebGL specification, not per implementation. It depends on the implementer. The array buffer have fixed size and you cannot access outside. There's no way. It throws an exception and you crash it. Your application crashes. Cool. What about unknown sources? It is known that if you load the texture, you may want to load the texture from outside your application. Basically, WebGL is following the CORS policy. So, the cross-sourcing origin assets basically are forbidden. What is validated using the policy can be loaded, and it's what every web framework is doing, actually. This is a kind of best practice. Last but not least, this is most difficult one is the denial of service. So basically, what's the problem? Is that you can have a loop inside your vertex shader, and let's say you wrote the bug. I did it. I do it every day, and the GPU hangs. Basically, it's doing stuff. As per WebGL specification, the implementers of the driver should implement the GL robustness, which is a specification for, let's say, for security. It allows the operating system to detect unusual activity. So to detect infinite loops or overrun of the GPU. So the WebGL implementation itself could be able to detect the GPU reset. I'm saying could because as of today this feature is available only on Windows 10. But by the way, the road, the path is there. It's just a matter of who is going to follow it. And that's all. Thank you. You can access the whole presentation and the code on GitHub. Actually, I'm stealing it from GitHub. Feel free to modify whatever you want and do it better because of the work needed. And are there any questions? About the WebGL framework?
We see an example from code example from Scene.js. I mean,
Scene.js
using the declarative approach.
Of course, this is not my code. This is from Scene.js website. And using it on the framework, we will create the depot, add it to the scene, then go into the rendering loop and modify the location of the depot. Here, instead, we're just declaring the scene in form of nodes. And you see, it's an actual JavaScript object. It is costing property. It is costing a modifier node, which is the location. So it is pretty straightforward. And moreover, it is useful if you have to deliver to represent data, because you can convert data to JSON or JavaScript object instead of building up the whole construction.
Does file in browser components support WebGL, like WebView or
actually, the WebView or the iOS WebView. JS is I don't know. I can imagine it depends on the system, but yeah, I don't know. Let's say I never used it because on Android I would be able to use the browser since 2012 because it was Android and not iOS, so I never tried to use it. That's because on Android WebGL was available since 2012, so I never had the issue to look for an alternative. viewer like the web viewer. But I'm not sure for example, so I don't know how the web view relates to the underlying rendering engine. Because for instance, on iOS, the problem is that when you develop a new browser, you have to use the same engine. So it is not allowed. It's not allowed. There is no way you can work around it. I can imagine one try to full work and say I will give it a try. And if there are no other questions,
is there an approach to use declarative in 3JS? JSON with
of course, it is slightly different, by the way, because you basically you pass a pure JSON object. You can load it. And you use actually an NSL loader. You load it and you pass it. You have to parse it and pass it to the underlying agent. So it's not that straightforward, and moreover, it doesn't allow for transformations. Like for instance here, sample, and not power mechanism. And close it. So in that example, we had the node rotate, which was telling the framework to apply rotation. In JSON, you cannot have it, or at least you have to implement your own, because 3JS doesn't allow it for now.
Thank you.
Welcome. And the last one is that we are hiring. As usual, everyone is hiring today. If you're curious, just go to the page.